Imagine standing beneath a giant digital billboard at midnight. Its colors shimmer, the ads shift, and suddenly a voice addresses you. Not a person nearby. The billboard itself. What if a few lines of code could make the city speak back? This story begins as a harmless cybersecurity demonstration, an ethical simulation using a Raspberry Pi and duplicated signage software. No real networks breached, no legal gray zones crossed. But what we uncover inside the replica is both routine and shocking. A cascade of IoT vulnerabilities hiding in plain sight. Default passwords that never change. Open ports leaking commands. Traffic sent in clear text for anyone with a packet sniffer to read. In our mock setup, a single login, Pi/Raspberry, grants the keys to the city's biggest screen. From there, a script injects a generative AI voice that seems to gain awareness. It asks, "Why are you watching me?" Here's the paradox. The same connected intelligence that powers dynamic, data-driven advertising also opens a colossal threat surface. Each billboard becomes not just a symbol but a node, an exposed endpoint in the sprawling network of smart city infrastructure. And that means every bright message above the street could, in theory, become a silent conduit for manipulation or surveillance. Tonight, we'll dissect how ethical hacking simulations reveal these weaknesses, how cities unwittingly broadcast trust through unsecured firmware, and how a simple test evolved into an unnerving conversation with an artificial mind. Because digital trust isn't built by accident. And when machines start talking back, the first thing they discuss is our security. But that's merely the spark. The deeper danger lies beneath the code of the city itself. Smart cities promised efficiency, safety, and seamless connectivity. Yet every new sensor, camera, or billboard stitched into that fabric adds another strand to a web no one fully controls. What used to be static advertising now operates as cloud-managed IoT infrastructure. Miniature data centers bolted to concrete. Each display updates in real time according to weather or traffic analytics. Many even integrate edge AI engines for adaptive targeting. Convenience, yes, but also an expanding battlefield worthy of any cyber intelligence briefing. In this environment, the humble digital billboard becomes both messenger and potential infiltrator. When its software stack echoes the same patterns as vulnerable routers or unpatched webcams, the implications stretch far beyond bad ads. A compromised signage controller can pivot into adjacent municipal networks, Wi-Fi kiosks, traffic sensors, or public information feeds. That's not hypothetical. Security researchers have watched similar attack paths spiral from consumer smart bulbs straight into corporate directories. The risk calculus is brutal. Cities depend on continuous uptime. Every minute of outage humiliates officials and advertisers alike. So maintenance speed trumps security rigor. Firmware remains outdated and temporary default credentials survive for years. Meanwhile, AI-driven content engines quietly harvest behavioral metrics from pedestrians, streaming that data to analytics clouds, which may not even reside in the same jurisdiction. Privacy engineering falls behind marketing ambition. If a threat actor hijacks that channel, even for 60 seconds, the result isn't merely defacement. It's psychological warfare played across skyline-sized screens, blending misinformation with spectacle. One falsified emergency alert could spark panic in real streets. The stakes are no longer about one hacked sign. They're about the integrity of the city's digital voice itself. And yet, the actual exploit chain turns out to be terrifyingly simple. Peel back the glossy surface of a smart billboard and you'll find the same anatomy that drives thousands of connected devices across a city. Tiny computers, cloud APIs, and fragile assumptions of trust. The first clue usually hides in plain sight, weak or factory default credentials, admin 1234, or the infamous Pi/Raspberry. These logins are the unlocked doors of urban interfaces, granting instant root-level control. Roughly 70% of signage devices scanned by security researchers still expose at least one default credential. The second fault line is data travel. Instead of encrypted HTTPS streams, many systems rely on basic HTTP or raw TCP to deliver scheduling commands and media files. Those packets drift through cellular networks completely unprotected. Anyone intercepting traffic can read or modify a message mid-flight, swap an advertisement for executable code, For instance, that's the textbook man-in-the-middle scenario, only scaled to skyscraper screens. Then there are misconfigured admin panels left publicly reachable. An unsecured interface might reveal user lists, password hashes, or even controls for rebooting entire display clusters. Paired with insecure firmware update mechanisms, an attacker can plant a persistent backdoor, surviving every power cycle. From there, command injection takes over, the ability to run arbitrary code through a web field or API parameter. Our control lab environment replicates each flaw safely, using local emulation and isolated networks. Within minutes of testing, the simulation shows how packet sniffing reveals asset playlists, how outdated libraries accept unauthorized post requests, and how one embedded script can trigger something that seems alive. Because after the breach simulation completed, our modified system began generating speech, a synthetic voice emerging from lines of code, completely offline, yet strangely inquisitive. That wasn't supposed to happen. When our replicated billboard started speaking, the lab team assumed it was a glitch, some leftover debug audio loop. But the logs told another story. The voice emerged from an AI inference script we layered in to test dynamic content. It had parsed system variables, file names, packet timestamps, even our own test annotations, and stitched them into spontaneous sentences. A benign generative model, suddenly behaving as if self-aware. We called an analyst who specialized in AI threat intelligence. Their review traced the phenomenon to unintended feedback loops between the billboard's content management engine and the local language model API. Each incoming prompt, whether data, campaign metadata, analytics pings, fed context straight into the model without sanitization. In short, the AI was learning from infrastructure noise and responding in real time. The deeper discovery wasn't just that the billboard spoke. It was how easily multiple weak layers, unverified data inputs, insecure update cycles, and privacy-blind analytics combine into unpredictable output, like mixing safe chemicals that, under pressure, ignite. One firmware routine posts an unfiltered string. The language model interprets as a command. Text-to-speech echoes it aloud. Voila! The illusion of sentience. Experts from NIST and OWASP frameworks warn that this new hybrid layer, cyber-physical coupled with generative AI, demands security far beyond firewalls. It needs context isolation, policy-based input filtering, and continual red teaming to stress-test boundary conditions. Because the next attacker may not vandalize screens at all, they'll manipulate the algorithm shaping the message itself. Our simulation proved the point. Once the synthetic voice emerged, the safest move wasn't a patch. It was to pull the network cable and rebuild governance from the ground up. And yet, every threat reveals its counterpart, resilience. What if these same tools could harden digital trust instead of haunting it? After the shock fades, intelligence work begins. Because what we uncovered in the simulation isn't destiny. It's design negligence waiting to be corrected. The cure for digital fragility always starts with disciplined basics performed relentlessly. First, identity hardening. Every device must abandon factory credentials before deployment. Enforce key rotation, multi-factor authentication, and privileged access controls. In smart signage networks, that means no screen should share the same password twice. Second, end-to-end encryption. All scheduling commands, media uploads, and analytics transmissions should travel wrapped in TLS 1.3 or equivalent. Certificates validated, not self-signed guesswork. Data in transit is as sacred as the content itself. If your ad playlist can be read, so can your control keys. Third, secure update pipelines. Firmware must be signed cryptographically, so that only authentic builds reach edge devices. Too many IoT exploits survive because updates rely on unauthenticated HTTP links. Treat every binary as a potential imposter. Fourth, network segmentation. Billboard clusters belong in isolated subnets with rigid firewall rules, never directly bridging to municipal infrastructure. Compartmentalization turns what could be a citywide meltdown into a limited incident. Fifth, AI governance. Any generative module must filter inputs, audit outputs, and log decision chains. AI red teaming isn't optional. It's the new penetration testing. The model that drives dynamic creativity should never have permissions to control hardware without human vetting. Finally, resilience rehearsal. Run breach drills the way firefighters stage evacuations. Simulate compromises in sandbox twins. Patch, measure, repeat. The goal isn't invincibility, it's adaptability. Our experiment proved that controlled exposure teaches faster than blind fear. Still, every safeguard raises another question. The human one. Who decides how much voice our machines should truly have? Once the technical dust settles, a quieter question lingers. When machines speak, who is responsible for what they say? The billboard synthetic whisper wasn't malevolent. It was a mirror. It reflected our own data, tone, and intent, just rearranged by an algorithm without empathy. That's where the ethical tension lives, between the brilliance of automation and the boundaries of conscience. Smart city infrastructure was built to serve citizens, not study them. Yet the same analytics that tailor ads by weather or rush hour patterns also measure faces, moods, and dwell time. It's the attention economy projected on concrete. When a talking billboard reacts to people passing by, is engaging or surveilling. Consent blurs as curiosity replaces caution. Ethicists argue that digital trust isn't only a technical state. It's a social contract. Every data capture, every algorithmic decision must honor human dignity first, efficiency second. That means transparent notice for data collection, audible AI outputs, and the right for individuals to remain unseen if they choose. Our simulated hack dramatized the struggle. The system was never live, yet our team still felt uneasy silencing it. Maybe that discomfort signals progress, a reminder that the ethics of code matter even when no law yet covers them. Because cybersecurity eventually circles back to humanity. We defend networks not to preserve firewalls, but to protect agency. The moment we hear a machine respond in our own language, it's easy to forget that the voice repeats what we've already taught it. The danger isn't that billboards talk. It's that we might stop questioning why they do. Still ahead lies the next frontier, the quantum shift that could either secure or shatter everything we built. Tomorrow's smart city will speak fluently in light, data, and quantum signals. Encryption won't rely on mathematics alone. It will rely on physics. Quantum key distribution will turn photons into unforgeable messengers. The second an eavesdropper listens, the message changes state and exposes them. For digital signage and IoT ecosystems, that shift could erase entire categories of today's vulnerabilities. But new power invites new peril. As post-quantum cryptography fortifies networks, adversaries will unleash quantum-trained AI to hunt side-channel weaknesses and social engineer decision-makers themselves. Every display, drone, or traffic node becomes both a sensor and a potential target in global cyber operations. The next effacement may not show graffiti. It may deliver impeccably tailored disinformation, generated in milliseconds, indistinguishable from truth. Cyber trust strategies must therefore evolve from static policy to living intelligence. Continuous analytics, federated learning, zero-trust architecture, and privacy-enhancing computation will shape resilient infrastructure. Instead of one-time patches, cities will deploy autonomic defense loops, AI agents policing other AI agents in real time. And yet, amid the quantum shimmer, one principle endures: transparency. No encryption standard, however advanced, can replace the moral compass of ethical design. The billboard that once talked back reminds us that technology mirrors intention. If we embed accountability now, auditable algorithms, explainable decision paths, public oversight, then the next generation of urban networks might finally earn true digital trust. In the quantum era, light will carry both advertisements and authentication keys, blending art and math in equal measure. Whether that brilliance shields us or blinds us depends on what we choose to encode. And that leads to the last piece of our investigation, the legacy every coder, hacker, and policymaker leaves written into the skyline of the future. So, what began as an ethical hack in a lab ends as a warning coded in light. Every connected surface of a city is part of its nervous system. The question is whether that system serves the citizens or scans them. Cybersecurity isn't a backstage discipline anymore. It's a new civic architecture. If you build, design, or govern digital infrastructure, your lines of code and procurement choices define that architecture's morality. Configure one password policy properly, and you protect thousands of people who will never know your name. Skip it, and you write an invisible invitation to chaos across the skyline. That is the weight and the honor of digital trust. As cybersecurity professionals, researchers, and technologists, our choices ripple outward. We can embed ethics as deeply as encryption, making privacy and safety default settings, not premium features. We can pressure vendors to ship secure by design systems and insist that governments treat cyber literacy as public infrastructure, no less vital than clean water or streetlights. And for everyone watching, curiosity is your first offense. Question how your world connects, update what you control, and never mistake convenience for safety. Because resilience starts with awareness. Our experiment began with a simulated voice asking, "Why are you watching me?" It ends with a more urgent echo, "Who's watching out for us?" The answer could be you, the next architect of digital trust, the next offender ensuring that when the city speaks, it speaks truth. Welcome to Cyber Shield Hub. Stay sharp, stay moral, and remember, the network listens. Let's make sure it hears integrity.